I'm going to show you Chorus. Chorus is a bring your own AI dev tool. The basic idea is simple. You keep using the AI coding tools you already like, whether it be Codex, Claude Code, or Gemini, or whatever comes next. And Chorus uses them for software development. So instead of asking one coding agent to do one task in a terminal, Chorus gives you a long-running AI engineering team. It turns goals into tickets, assigns those tickets to agents, run the coding tools in isolated work trees, and opens pull requests for you to review. You are still in control. Chorus does the implementation work, but you decide what gets merged. One of the most important things about Chorus is that it's not trying to replace your favorite AI coding tool. I personally use Codex and Claude Code a lot. Other people may prefer Gemini CLI. Chorus is designed around that. Bring your own AI, bring your own subscriptions, and Chorus provides the coordination layer around them. Under the hood, Chorus gives you a full shell running on a containerized node. That means you can run Codex in YOLO mode or Claude Code with permission prompts skipped without worrying about them damaging the rest of your data. And this is one of my favorite parts. I run it on a very old MacBook Air that my wife gave me. It's a 14-year-old machine running in clamshell mode, and it's been working wonderfully. On the left, you can add new projects. Each project is connected to a GitHub repository. The repository can be public or private. Chorus uses your own GitHub account to clone repositories, create branches, and open pull requests. Here, I have 4 demo projects added. Each one can have its own goals, specs, tickets, agents, and development workflow. When you create a new project, you point Chorus at a GitHub repository, then you can describe what you want the system to build. I use Chorus to implement Chorus itself. This is Chorus developing Chorus. Here you can see that I have defined the high-level goals, the safety guardrails, and the specifications for the system. You are defining the operating envelope for an AI engineering team. The goals tell the agent what the software is trying to become. The specs tell them what good implementation looks like, and the guardrails tell them what they should not do. That lets the system develop software autonomously, but conservatively. It can make progress, but it is still constrained by the rules and directions you give it. You can define tickets manually inside the system, or you can give Chorus a high-level goal and ask it to create tickets for you. The reason I call it conservative is that Chorus doesn't just continuously rewrite your software with no structure. It breaks works into reviewable units. Each ticket becomes its own implementation attempt on its own branch with its own logs and pull requests. So the loop is goal, ticket, agent work, branch, pull request, and then human review. That is the key design choice, autonomy under your control. The Tickets tab contains a simple ticketing system. You can define your own tickets when you know exactly what you want. For example, add this feature, fix this bug, or refactor this module. Or you can ask Chorus to create tickets based on the goals you have given it. That is the mode I use a lot. I describe the direction of the project, and Chorus decomposes that into actionable engineering work. Each ticket is implemented on a separate branch and work tree. When the agent finishes, Chorus pushes the branch and opens the pull request against your repository. So even when the system is working overnight, it's not directly modifying your main branch. At the end, you get the PRs. You review them. You decide what goes into your software. Chorus also lets you define different agents. You can create agents yourself or pull them from the agent gallery. These agents collaborate to build your software. For example, you can have one agent responsible for proposing new features, another agent responsible for code review, another one responsible for testing, and another agent responsible for implementation. Realistically, the majority of the development work falls on the poor agent here, the software developer. The nice thing is that these agents are not magical black boxes. They have definitions, skills, permissions, and responsibilities that you can inspect and change. As the agents work, you can see how they communicate through the state machine. This was pretty useful to me. You can inspect the agent chatter, the transitions, and the reasoning trail of what the system is doing. And Chorus can use that information to self-heal. For example, it can read the agent chatter and figure out whether your agents are running efficiently. Maybe an agent is too verbose, maybe it's missing a skill, maybe it has too much permissions or not enough permissions. Maybe 2 agents are duplicating work. Chorus can then rewrite agent definitions, add skills, or remove permissions to make your army of agents more efficient. I use this a lot, so can efficient agents reduce both cost and time. If agents communicate clearly and use the right tools, they can build software much faster. Agents can also communicate with you as their human orchestrator. Sometimes they need more power, sometimes they need a new tool, sometimes they realize that a new agent would help them do better work. Those requests appear in the Suggestions tab. I like this workflow because it creates a feedback loop between the human and the agent team. The agents can tell you what is slowing them down, but they do not automatically get unlimited authority. You can review the suggestion and decide whether you want to approve it or not. Again, the theme is autonomy with control. For anything else, you still have access to the full terminal. I love this because I can manually check the code, inspect the repository, run commands, or use my old software engineering skills when I want to. Chorus also has a set of tools that agents can use. For example, agents can file pull requests, read pull requests, address comments, merge when allowed, or interact with tickets. You can add new skills and assign those skills to agents. So if you want a specific agent to be able to do code review but not merge PRs, you can model that. If you want another agent to manage tickets but not touch production code, you can model that too. This is important because real software development is not just writing code, it's tickets, branches, comments, reviews, tests, and pull requests. Chorus tries to give AI agents the same workflow shape that human engineers use. The last thing I want to show you is why Chorus is useful as a long-running system. Because Chorus uses an internal web server and dashboard, I do not need to keep a terminal multiplexer open. I do not need to keep my laptop lid open. I can leave Chorus running overnight. It can implement tickets, improve the software, and file pull requests while I'm away. Then when I come back, I do not have mysterious changes on my machine. I have reviewable pull requests on GitHub. That is the workflow I want to let the agents work, but keep the merge decisions to me. So that is Chorus. It is a bring your own AI engineering team that works with the tools you already use, Codex, Claude Code, or Gemini, and wraps them in projects, tickets, agents, tools, logs, and pull requests. I hope you enjoy Chorus as much as I do. Eventually, I would love to build a hosted platform so people can run Chorus in the cloud without maintaining their own machine. I have not had enough time to work on that yet, but I already use Chorus a lot locally. It complements my Claude Code and Codex workflows really well. And the ticketing system has become one of my favorite parts. Thanks for watching.